Today, we're diving into the massive world of marine shipping, and we're going to uncover why this huge industry, the one that moves pretty much everything you own, is actually the perfect first customer for a new sustainable fuel called pyrolysis oil. So let's just get this out of the way first. You see electric cars everywhere, so you gotta wonder, why can't we just slap some giant batteries on these massive cargo ships and call it a day?
Well, it really just comes down to physics. The sheer amount of power you need to push a vessel the size of a skyscraper across an entire ocean is just astronomical. Batteries aren't even close to being able to pack that kind of punch, and that means the shipping industry is going to be locked into using liquid fuels for a long, long time.
So here's our roadmap for today. We'll start with why shipping is such a hard-to-abate problem. Then we'll get into why it's also the perfect low-hanging fruit. We'll cover 3 key technical hurdles, look at the new rules that are changing the entire game, and finally, talk about the massive billion-ton opportunity.
Okay, first up, the hard-to-abate problem. You hear this phrase all the time when people talk about going green. And shipping, it is the textbook example of a sector that's a huge challenge, but also a massive opportunity.
And here's the bottom line. If you're a company that's figured out how to make a new fuel from waste, say old tires or plastics, you need a customer, and you need one fast. The marine market is just the perfect target. Why? Well, because it's just easier to get started. The fuel specs aren't nearly as strict, and the pool of potential buyers is absolutely enormous.
And that right there brings us to the main idea for today, why marine fuel is what we call the low-hanging fruit. And it really all comes down to what's happening deep inside the ship's engine room.
Just look at this comparison, because it says everything. The engine in your car is this delicate, high-tech machine. It needs super clean, highly refined diesel, and making fuel that pure costs a lot of money. A ship's engine, on the other hand, it's a brute. It's built from the ground up to burn the cheap, heavy, nasty stuff. That difference is the whole ballgame.
So let's break that down. Your biggest ships, we're talking supertankers, massive container ships, they use these enormous 2-stroke engines. These things are incredibly tough. They can burn fuel that would literally destroy a car engine in seconds. And even the smaller 4-stroke engines on things like ferries are still way more tolerant than anything you'll find on a highway.
Now, this doesn't mean it's the Wild West. There is a rule book. It's called ISO 8217. And you can think of it as the official guide that lays out exactly what can and cannot go into a ship's fuel tank. For a pyrolysis oil producer, this gives them a clear target to aim for, and importantly, it's an achievable one.
Okay, so it's not quite as simple as just pouring it straight in the tank. There are a few technical challenges you have to solve before this stuff is ready for the open ocean. So let's look at the 3 main hurdles, which really are just engineering problems that we already know how to fix.
All right, hurdle number 1, and this is a big one for safety, the flash point. This is a super important safety check. It's simply the lowest temperature where a fuel starts giving off enough vapor that it could catch fire.
In the maritime world, there is a golden rule, a magic number you absolutely cannot ignore: 60 degrees Celsius. This is required by an international safety treaty. A ship's fuel must have a flash point above this temperature. It is non-negotiable. And the problem is, raw pyrolysis oil often doesn't meet that standard.
So how do you fix it? Well, the solution is a pretty straightforward process called light end stripping. You basically just heat the raw oil, which lets the really volatile parts, the light ends, turn into vapor. You pull those vapors out, and what's left behind is a fuel with a much higher, much safer flash point. It's a pretty low-cost fix that's absolutely essential.
Okay, hurdle number 2. We've got to talk about sulfur. Back in 2020, the International Maritime Organization brought in a game-changing new rule that dramatically cut the amount of sulfur allowed in marine fuel. The global limit went down to 0.5%, and in really sensitive areas like off the coast of Europe and North America, it's an even stricter 0.1%. Now this is where it gets really interesting, because what you make your pyrolysis oil from makes a huge difference. Oil from all tires, it's naturally high in sulfur, way over the limit. So you either have to pay to clean it or find a ship that has a special scrubber system. But oil from waste plastics or biomass, that's a whole different story. It's naturally super low in sulfur, which makes it incredibly valuable as a blending component to help other fuels meet the rules.
And that brings us to the last hurdle, compatibility. Some of these oils can be a bit acidic, which can corrode things like fuel pumps or tanks. Others can attack rubber seals and hoses, causing them to fail. The good news is, these are well-understood problems with known solutions, managed by treating the fuel or just using tougher materials on the ship.
All right, so we've covered the tolerant engines and the technical fixes, but now we get to the part of the story that's truly forcing this change. We're talking about powerful new regulations that are creating huge financial reasons to go green.
A huge driver here is a European regulation called FuelEU Maritime. Starting in 2025, it's forcing ships that use EU ports to steadily reduce the carbon intensity of their fuel. And as you can see, those cuts get deeper and deeper every few years. This isn't a friendly suggestion, it's a mandate, and it's creating a guaranteed and growing market for low-carbon fuels.
And then there's the hammer. The EU's emissions trading system, which is basically a carbon tax, now applies to shipping, and it is a big one. Right now, it adds somewhere between 250 and 320 euros to the cost of every single ton of regular fossil fuel. Suddenly, for the very first time, this tax makes low-carbon pyrolysis oil economically competitive, even if its sticker price is higher.
So, when you pull all these pieces together, the tough engines, the solvable technical issues, and these powerful new regulations, you start to see this incredible billion-ton opportunity taking shape.
I mean, just try to wrap your head around this number. Every single year, the global shipping fleet burns through more than 300 million tons of fuel. If you're a new fuel producer, capturing even a tiny slice of that pie is an absolutely massive market.
And this really gets back to the core business decision, this idea of the value cliff trade-off. Look, sure, you could spend a fortune refining your pyrolysis oil to meet the crazy strict standards for road diesel and sell it for a high price. Or you could spend way less on just a bit of processing, sell it to the marine market for a little less, and probably make a much better profit. It's the smarter, faster way to get your product to market.
So if you want to succeed here, the playbook is pretty clear. Number 1, get that flash point above 60 degrees Celsius. That's non-negotiable. 2, manage your sulfur. 3, test every single blend for compatibility. And finally, number 4, get certified as low carbon. That's how you unlock a huge financial upside from all these new rules.
And that leaves us with this final really big question. We have the technology, the engineering problems are all solvable, and now, for the first time ever, regulations are making sustainable fuels the smart economic choice, not just the right environmental one. The path forward seems clear. So, are we about to witness a full-blown revolution in how we power global trade?